Hello, this is Barrett from the C4 Cyber Club here at Cypress College. In this video, we are going to cover Lab 3 from the CIS 230 Cisco Networking 1 class, or you could also call it the Cisco Network Academy Lab 3.7.10, which is all about using Wireshark to view network traffic. So what you want to do from your Netacad accounts, the lab page, lab 3, you'll want to click on this document file, which is what I'm looking at right here. And this is what you'll use throughout the lab. And you'll see that there are questions to answer throughout. There's maybe 6 or so questions, I believe, but we'll go through them one at a time. So this is what you will fill out and turn in as your assignment for this lab. You'll also want to make sure, if you haven't already downloaded Wireshark, you will need that for this lab. You can go to wireshark.org/download.html to download that. And you can see I have mine running in the background here. This is the very first screen that you see, where you have to choose the particular network interface that you want to capture traffic on. So we'll come back to that in just a moment. Okay, so let me go ahead. Whoops. Let me go ahead and minimize this. We don't need the web browser. Bring up Wireshark. Okay, so what this lab is all about, we're going to capture network traffic, both on our internal systems, and then also we're going to capture traffic that we're connecting to remotely or out on the internet, essentially, remote hosts. So we'll be working with Icmp ping requests, and the first part of the lab, we're thinking only internally, only local data. In part 2 of the lab, that's when we're going to start. We're going to ping, outside websites like google.com, cisco.com, and I believe yahoo.com. So you may be thinking, okay, what is Wireshark? What is packet sniffing? So in the scenario here, it describes it all really well. Wireshark is a software protocol analyzer or packet sniffer. It's used for network troubleshooting, analysis, software, and protocol development. And as we're doing right here, for education, right? So we're using this to get a detailed look at what happens when you make a ping request, and how this data transfers between networks. As data streams travel back and forth over the network, the sniffer captures each protocol data unit, or PDU, and can decode and analyze its content according to the appropriate RFC or other specifications. So these captures, you'll probably remember from the sample quiz for this week, we looked at what were called PCAP files. And that is essentially a Wireshark capture that was kind of frozen in time from the moment all of those packets were captured, and we were able to analyze that. So that's essentially what we're doing. We're going to capture real-time network traffic happening on your own network at home, and then we'll be able to look at those ping requests that we make. So required resources, you just need essentially just your one PC. Now, this was back when this was done, on campus. You had a teammate in your classroom, and each person's computer obviously had its own separate internal IP address. So it was really nice to work with with a partner on this. But you can do this at home as well. You could potentially, if you maybe have a desktop PC and you have a laptop, you could get the IP address of your laptop as well, and you could ping back and forth between those two. But in the video, I'm going to do what a lot of you may also want to do, and you could just ping your default gateway or your router. And I will show you in a little bit how to get that information, how to get that IP, and also MAC address. So since we're all doing this at home, I'll use that as the main example, since that would be the easiest option. So in part one, we will capture and analyze local ICMP data in Wireshark. So first things first, we need to figure out, okay, what is your local IP address or your private IP address? And as you work on this, don't worry. Even if you share this documents, this information with others, this is all internal. So you're not, you probably hear the phrase, don't let anybody ever know your IP address. And I obviously wouldn't be recording this if it was bad, but your internal IP addresses don't relate to how other people can connect to you. That would be if it's your public IP address, which is your public facing end of your router. That is something that you don't want to share. But in this case, we'll be working with only internal IPs for our own private, network. So what we want to do, we could run ipconfig and then /all. And this is a tool that we could use to gather all of the details of our internal network. And so me personally, I'm going to be looking at my wireless adapter, because this PC that I'm running on is connected to the wireless network. You may see something different if you're plugged in to a cable. You'll see under probably Ethernet adapter here somewhere. So, but also I think a lot of you will probably also be working on your wireless as well. So what I see here, I have my IPv4 address right here. And then I'm also going to take note of my physical address or my MAC address. And what I'll do, and I would recommend you do it as well, I'm just going to pull up Notepad. And I'm gonna note these down. So I'm gonna say, okay, my IP address is 192.168.39.121. So now this 192 address, this is a private IP address. Other private IP addresses you may see begin with 10, and then others also begin with 172. And even if you hold up, you could Google private IP address ranges. If you ever forget this, and there's some pretty handy images you could pull up. So you could see anything from 10 to 10.255.255.255. That's a private address space. Now 172, it's only going from 172.16 to 172.31 is a private IP address space. And then 192.168 is a private address space. And you can see that is the one that I am in here. Now I'm also going to note my MAC address. That's C0E434. And then also, I mentioned how we're going to be pinging the default gateway. You could find that information right here as well. And you've probably heard me mention before that the default gateway is always going to end with the host .1. And this also is pretty much another way of saying your router. Okay. So we have that. Eventually, we will get to finding the default gateway MAC address. We'll come to that in just a little bit. So you could see that this information looks pretty similar to what's on the lab here. Obviously, this lab is different. It was scanned on a totally different machine. So, your information is not going to look identical to what's in the lab document. So, okay, ask a team member for their PCIP. We'll skip that at this time because we're going to be using the default gateway. Okay, so we want to navigate to Wireshark. And straight away from this opening screen, we want to select the interface to capture. So I'm going to capture my Wi-Fi. I just double click. You can see right away it's capturing a bunch of random packets that are happening. All, home networks have all sorts of information being passed around. So what I'm going to do first is come up to this display filter. And in this lab, all we're looking for is Icmp packets. So I'm going to type in Icmp in all lowercase. See the bar turn green. I'm going to press enter. And you're going to say, okay, did that just delete everything? Well, no, because it's still doing the capture. We're just filtering the display. If I X'd out of this display filter, you see it's still capturing the background. We're currently at 1,200 packets right now. So I'm going to go ahead and refilter with Icmp. It's super important that it's all lowercase. If you did uppercase Icmp, you see that bar is still red and it does not take the filter. So those always have to be lowercase. Okay, so we have that filtered. You could see that in the B section here, the lab does go over that as well, typing in that filter. Great, so now we're at a place where we can go ahead and make our first ping request. So remember, we're going to be pinging from our machine. We're going to ping our default gateway. So remember, your numbers will be different than these. So don't ping what's on, my screen here. Make sure you ping from the information that you gathered about your home machine. So I'm going to come back to the command prompt. And we'll just type in ping 192.168.39.1. Okay, so we see the pings going through here. Windows by default sends 4 ping requests. So I'll minimize this. And now, because we had this filtered, we see all of these Icmp packets. So the very first, let me break down what's happening in these different Wireshark columns here. So we have number, and this is the packet number. So as we mentioned before, we've been capturing packets for a while now. So we're already up to number 2,438. The time shows you the time that has passed. So we went from 117 to 120. So we could say that this ping took about 3 seconds. The very first packet, as we can imagine, that's the ping request. So it makes sense that the source IP comes from my IP address. And the destination, the .1, is of course default gateway. We see that these are listed under the Icmp protocol. Great. So, and also you could see, if you look in this middle window here, you could drop down the Ethernet 2 frame. That's going to give you information about the source and destination MAC address. So the source, of course, is my PC. And that matches that. And now right here, we can say, okay, we just determined what the MAC address is for the router. So I'm going to actually note that down as well. Router MAC address. That'll definitely come in handy when we're analyzing some other packets. Okay, so back to the lab. We did that first ping. Okay, we took a look at that information. And also, I think at this point, we can go ahead and stop this particular capture. And we'll just be examining it. So we get down to the questions here. Does the source MAC address match the PC interface? Yes, we confirm that the source right here matches. Does the destination MAC address in Wireshark match your team member MAC address, or in this case, it's our router? So that's actually a good question, because you could say, well, how do we know for sure? At this point, we're trusting that Wireshark is reading that correctly. But what we could do, and this kind of takes into consideration this third question here. How is the MAC address of the pinged PC obtained by your PC? Well, this is done by what's called an Arp request, or address resolution protocol. So, and I could actually change this display filter and search for Arp. And so you see all these Arp requests here. What this does, it sends out a broadcast message. You see that under destination here, broadcast. And it's essentially saying, okay, who has such and such IP address? And you see in this case, it's saying tell 192.168.39.1. And we actually know that to be the router. So, which totally makes sense, because, your network has a bunch of different machines, and it's always going to have to go through the router, especially if it's connecting to the internet. So what that router will be doing, it'll be creating a table of MAC addresses and how they relate to the IP addresses that make these kind of requests. So that's how, through this Arp request, that's how we come to find the MAC addresses of particular machines. So what we could do to kind of verify, I'm going to change this back to Icmp filter. This is kind of a little bit outside of the lab. I don't believe the lab goes over this. But what I would essentially do is run the Arp command in the Windows command line and do -A. And this is actually going to show you some of the Arp tables that have already been populated on my machine. And so I'm finding the interface for my IP address. And essentially what you want to look for, find the IP address of the router. We see that right here. And so I can actually reconfirm the physical address or MAC address of the router. So that looks like that was correct. So we can confirm that what we see here in Wireshark was indeed that MAC address. Great. So yeah, so once again, how is the MAC address of the ping PC obtained by your PC? Very simply, the MAC address is obtained through an Arp request. Okay, so we will move on to the second part of the lab, capturing and analyzing remote Icmp data. So this is where we're going to be pinging outside websites. And so I've already stopped the capture. So we're going to create a new one. Get out of there. Let's go to capture, and then just start. And you can say continue without saving. You don't need to necessarily save that PCAP file for anything. Okay, so you can see it started a new fresh capture. I'm going to go ahead and filter by Icmp again. And I will pull up the command prompt again. Just go ahead, type CLS, clear the screen out. Okay, so review the captured data. Okay, no, I'm jumping ahead of myself here. Okay, so we just want to ping these three websites. Ping www.yahoo.com. You could already see that happening in the background here. So you could potentially ping these all at once, or you could take them one at a time. I think I'm going to take them one at a time just so we could look at each chunk together. So we know that our IP address is this .121. So that makes sense. That's the first packet here, the source. And the destination is this 74.6.231.21. Now this is a public IP address. And so this is the IP for yahoo.com. So in your lab, you could just enter that in. I usually like to choose a red font. 74.6.231.21. And then it's going to ask, well, what is the MAC address for that? So this is kind of a trick question because as we kind of talked about going over the sample quiz as well, if you are pinging a remote system or something external out of your own network, out of your local area network, you're not going to receive back the MAC address of that outside machine. What you'll receive back is the MAC address of your router. So, the answer to this question, and you could see this in the destination MAC address here, it is the same as our router. Because, that the information you requested from yahoo.com, it comes back to you through your physical router. So, you could use this as the answer. And I would probably just make a note, default gateway router. And then we move on. Now we go to cisco.com. So we'll do ping www.cisco.com. You see those being captured here. It's interesting. I actually have a ping request that popped up here that I don't believe I myself initiated. So I'm actually going to have to take a look into that. So ignore these ones right here. What we're looking at is this new bunch here. So we know that 192.168.39.121 is my internal IP. So we're looking at 104.79.128.77 as the Cisco address. So I'll just go ahead and enter that in here. 104. And so what is the MAC address for cisco.com? Well, trick question again. We don't know the MAC address of that Cisco server or website, but what we get back is our router or default gateway MAC address. So the answer for those, are the same. IP address of google.com. We come back to command prompt. Ping www.google.com. You could see here, it even gives you the IP address right here. Essentially, it's doing a DNS request. You're gaining that IP address straight away from this ping request or from the ping tool. You could even use that as reference. And of course, we could verify that in Wireshark. Source IP from our internal destination to google.com IP address. And of course, the MAC address answer is going to be the same because we're pinging an external site or host. We can't know their MAC address. It will only come back as our default gateway. So what is significant about this information? Well, essentially what we just said. The IP addresses being different here is not significant. That's expected. So I suppose what's significant is that the MAC address results are all the same, and of course, they all point to our default gateway. So how does this differ from the local ping information? When you ping locally, that's going to return the MAC address of the PC's network interface card, right? It's going to return that physical address. But when you ping a remote host, it's only going to return the MAC address of your default gateway or the local area network interface. So that's essentially the responses for those questions. Okay, looks like we got to the end here. So the reflection question: why does Wireshark show the actual MAC address of the local hosts, but not the actual MAC address for the remote hosts? It's essentially that's what we just went over. It highly relates to these two questions here. I'm gonna leave you to kind of reflect on that question. You could definitely find a lot of really nice information online about this as well, just by Googling. I encourage you to kind of like look into this a little bit more. And you could also look into how this relates to the OSI layer model also. What's the difference between layer 2 information and layer 3? You have the data link layer where MAC addresses reside, those physical addresses. And then what's the difference between that and layer 3, the network layer, and using logical IP addresses? That is definitely something that you'll gain a much more deeper understanding of this question in your reflection on that. So great. So that covers this lab 3.7.10 using Wireshark to view network traffic. And thanks a lot for watching.